Okay, today we're talking about the binomial theorem. Binomial theorem. And you guys know what a binomial is. It's just something like x plus y. It's a binomial, two terms. Okay? What we're going to do now, though, is we're going to raise this to a power of n. And we want to try to come up with a better way or an easier way to find the coefficients of the terms that are going to happen when n gets to be bigger. Okay? Because we know that x plus y to the 1 is just x plus y. We should also know that x plus y squared is not x squared plus y squared. It is, you have to FOIL that, right? So it's x squared plus 2xy plus y squared. Okay? If we have x plus y cubed, x plus y cubed, we would have to take this x squared plus 2xy plus y squared and multiply that by another x plus y. Okay? And that's going to take a little bit of work. You guys have done that probably before with a cube. But we want to be able to get up to whatever, the power of 8, power of 9, power of 10. Okay? So we don't want to keep multiplying this stuff out. Now this one's going to come out to x cubed plus 3x squared y plus 3xy squared plus y cubed. If you do all that multiplying and distributing and combining like terms, this is what you will end up with. Okay? Now obviously as this gets up to the 4th power, 5th power, 6th power, that's going to be a lot of work. Alright, so that's what this binomial theorem is a way to do this more easily. And not have to do all this distributing and multiplying. Just it's a way to find these coefficients. Okay? So there's two ways. First way that we're going to talk about is each of these coefficients right here, like this one, and this one, and this one, and this one. Okay? The coefficients of each term. Well, this is a 1 right here. This is really a 1, right? Because there's no coefficient there. That's a 1. Well, that happens to be 3c0. Anything c0 is 1. Okay? This happens to be 3c1. This happens to be 3c2. This happens to be 3c3. Okay? So you can use combinations to get those coefficients without having to do all the multiplying and distributing it. Okay? So let me do another example here. So if we just have a plus b, let's say to the 5th power. Okay? A plus b to the 5th power. Well, I know first of all that's going to be 6 terms. It's always one more term than the exponent. Okay? It's going to be 6 terms. I know that my coefficients for those 6 terms are going to be 5c0, 5c1, 5c2, 5c3, 5c4, 5c5. Okay? What do those come out to? You can put those in the calculator, or you can do them by hand. Anything c0 is 1. All right. Also, anything c itself is also 1. Okay. And these are going to come out to anything c1 is just the original n that was there. So this is 5. 5c2 happens to come out to 10. 5c3 comes out to 10. 5c4 comes out to 5. And notice how these are always going to be symmetrical also. Okay? They're always going to be symmetrical. So those are my coefficients. Alright, so I'm going to put those in front of my a, b terms. And to know what to do with the a's and b's, all you have to do is the a is going to start at n, or 5 in this case. So this is going to be 1, a to the 5th, b to the 0. So the a starts at the top and counts down. The b starts at 0 and counts up. So this is going to be plus 5, a to the 4th, b to the 1. You don't have to put the 1 there. Just to show the pattern here. So plus 10 a cubed b squared plus 10 a squared b cubed plus 5 a to the 1 b to the 4th plus 1 a to the 0 b to the 5th. Okay? And now you can simplify this, this first term and last term. Anything to the 0 is 1. So this just drops out. This a to the 0 drops out. So that's just really a to the 5th there. And this at the end is really just b to the 5th. Okay? And then you have all the other terms in between. So the coefficients come from these combinations. The exponent of the first term starts at this n right here. This 5 is this original exponent. And counts down 5, 4, 3, 2, 1, 0. And the second term, the b in this case, starts at 0 and counts up from there. Notice how if you add the exponents of any of these terms, it comes out to 5, which is this. That's that 5 again there. So the exponents always have to add up to this original n. Okay? Let's see. Just a couple quick little things here. NC0, anything C0 always equals 1, and anything C itself always equals 1, like I said. And then, of course, the exponents, like I said, exponents have to add up to n. Okay. So that's using combinations. There's another way, which is called Pascal's triangle, which I think you guys have probably heard of before, Pascal's triangle. Pascal's triangle's a nice thing to use if you have a bunch of these problems you got to do. It's not that useful if you just have one question that's like to the 12th power, because that's a big triangle to make. But Pascal's triangle just says 1, 1, 1, and then you add the two numbers above. And the outside edge is always 1. So we've got a 1 here. This is now a 2. That's a 1. Now we got a 1, 3, 3, 1. We got a 1, 4, 6, 4, 1. And we've got a 1, 5, 10, 10, 5, 1. Now that should look familiar. That's the example I just did. 1, 5, 10, 10, 5, 1. So this is where n equals 1 here. Right? That would just be a plus b. This is where n equals 2. That's a plus b squared, which comes out to a plus b squared comes out to a squared plus 2ab plus b squared. That's this 1, 2, 1. Alright, and so on. So n equals 3, n equals 4, n equals 5. Those are all the coefficients. Okay? Oh, let me give you one other notation here too. This is just a side notation, but if you see something that looks like this in parentheses with the n over the r, that's just the same thing as NCR. That's just the same thing as doing the combination n objects taking r at a time. Alright, it's just a different notation for it. Okay? Let me pause this and continue in a sec.